Another important thing is the pre-processing of the data, which is very crucial step in any machine learning application or pipeline. It is very important because when we acquire data or when we capture data through any source, the source can be a video camera, it can be a sensor, so it can be any hardware device that is generating data or through which we are capturing or acquiring our input data. So it happens in most of the time that the acquired data is not of very good quality, and we are unable to feed it to our machine learning algorithm if the data is of bad quality, because our algorithm will not be able to converge if we are providing it a bad quality data. And the data can be of bad quality through many ways, right? For example, there can be noise present in the data. The data can have repeated values or redundant data in, and there can also be a possibility that there might be some missing values in the data, right? So let me give you an example of a bad data set. For example, I am working on a video surveillance application, and I want to um, uh, perform some video processing tasks on that video data. For example, I want to perform some object detection, or maybe I am interested in classifying some objects from the video stream, or maybe I want to perform segmentation of different objects in the video stream. And if it normally happens that in real life scenarios, when we have different sorts of video cameras present on roadsides or in some buildings, then it can happen that due to weather conditions, maybe, or maybe through some other reason, we can have bad quality data. For example, I can have blurred video frames, or there can be variation in lightning, because it can happen sometimes that if we have a very bright sunny day, then the lightning conditions may be quite vary in different video frames, right? We can have high intensity values because of the bright daylight, and on the other hand, if I have a cloudy weather, then in that case I have low intensity values, right? So in both of the cases, I will say that the quality of the input video frames are not good, and in that case I will have to apply some pre-processing techniques or pre-processing algorithms in order to bring the video frames to a good quality, right? So there are many image processing techniques which we can use in order to get rid of these challenges. But all these things comes into the data pre-processing step, right? So data pre-processing step is very important in most of the application, despite of the fact that it doesn't matter that we are using some video processing, or it is some textual data, or it is some images. So even in the case of audio signals, there can be some noise present in the audio signals, and we have to pre-process it. So data pre-processing is a very vital and crucial step in most of the machine learning applications. So we can see that in data pre-processing, we are more interested to look that whether is there anything wrong with the data, right? For example, we can see that if there are some missing values in the data, or maybe there are some outliers present in the data, maybe because of some noisy patterns, or there is bad encoding if I have some textual data, or it can also happen that I have some wrongly labeled examples. Wrongly labeled examples mean that if I am working with the labeled data and I am executing some supervised learning machine learning algorithm, then it can happen that maybe I have some samples related to category A, and due to some reasons they are labeled with the category B. So in that case, the data will be a wrongly labeled data, and and despite of the fact that I have trained my algorithm with very good tuning parameters, but even my algorithm will not be performing good in that case, because the input data set is wrongly labeled data set. So I need to fix that before I provide these examples to my algorithm. Also, there is a possibility that the data is biased, and I will have to see that do I have many more samples of one class than the rest, because that can also lead to the class imbalance problem, right? So there can be a number of issues which needs to be fixed or removed from the data, and all these things should be carried out in the data preprocessing step, right? So as an example, you can see in this figure on the right hand side that in this chart or graph, you can see that there is a uniform pattern in all these instances or samples. But this sample is acting as an outlier in this case, and we need to remove this outlier before feeding this data to our algorithm, because this outlier will drop the performance of all other training examples. Similarly, if I have this kind of data set and I have some odd values in this data set, then it's better to remove these odd values and clean my data in the pre-processing step. So again, I will repeat that data pre-processing is a very crucial and important step. Whether you have some images, videos, textual data, or binary data, or numerical data, in all these cases, you need to first fix the data set. You need to first remove the bad things in the data, and then you can provide it to your algorithm and you can proceed to the next important steps. So the other important thing is the feature engineering, and feature engineering in machine learning is a very vital and crucial step, similar to data preprocessing, right? So first we need to understand that what is a feature, what things are we treating as feature in machine learning, and how can we do feature engineering, right? So there are two things. So what is a feature? A feature is an individual measurable property of a phenomena being observed, right? So this is a very classical definition of a feature, which means that it should be a quantifiable or measurable property, and it can be an individual property which should be measurable and quantifiable, and it can be related to any phenomena that is being observed, right? So this phenomena will be dependent on the application or the type of the data set, right? But the common thing is that the feature, the thing which we are treating as feature, should be measurable and quantifiable. Our inputs are represented by a set of features. So the data which we are providing to our machine learning pipeline, that data set contains or consists of a number of features, right? So we are saying here that the inputs which we are presenting to our machine learning pipeline has a set of features. So there will be more than one features or a number of features which we are presenting to our model, right? And our model will basically be extracting those features, and it will perform its learning on the basis of those features, right? So there are many properties and characteristics of feature which we will discuss later on in more detail.